Okay, our next speaker will be Dr. Sallie Baliunas, and the following speaker, her colleague Willie Soon. They're both astrophysicists at Harvard-Smithsonian, work at the Mount Wilson Observatory. A remarkable amount of the original science, of the organizing of the science that exists from other places, and of the political activity to oppose the global warmers comes from these two people. I was just thinking about the fact that they have thousands of times less financial resources than the people they oppose. At first this seems unfair, but it really isn't, because it's much easier to prove things that are true than to prove things that are not true. So if you're trying to prove something that isn't true, you need a lot more money. Dr. Baliunas.
Thanks so much. Well, you've got to be a believer. That's the arresting opening line of one of my favorite science fiction stories, The Man Who Sold the Moon, written by Robert Heinlein in 1949. And in it, the protagonist of the story is an industrialist named D.D. Harriman. And D.D. wants mankind to do something very ennobling, to go to the moon. So he takes his vast personal fortune that he's gotten from the benefits of capitalism, and he applies marketing techniques to convince humanity that they must reach for the moon. And he spends his entire fortune and career and life doing that. Now, these marketing skills, I'm not opposed to them. Marketing is essential. It's also a very interesting window on human nature. For example, what we tolerate on billboards tells a lot about our culture, what we're willing to expose our children and our great-grandparents to. So there is a place for marketing, but marketing is a social contract that depends on social pressures and fashion. Science is the opposite of that. Science is a social contract that says, no, we do not rely on fashion. We rely on the scientific methods. We discern facts, put them together in a hypothesis, and we, with razor sharpness, eliminate the hypothesis if it doesn't hold the facts. Yet I have to look at the latest United Nations Intergovernmental Panel report on climate change, the IPCC report, the third assessment report. These have been done periodically since 1990. And you'll read in the newspapers that the 2001 report is being released this week and next, in tune with the meetings, the Conference of Parties meetings about climate change in Bonn, Germany. Now, the problem with the TAR report is the policymaker's summary. And the policymaker's summary is marketing, not science. And it was not written by the scientists. In fact, scientists who reviewed it early on said it was definitely, they opposed material in it, yet it was not taken out in the so-called peer review. So we know it's not peer-reviewed. I want to go through some of my favorite things, least favorite things, that is, in the third assessment report, because you'll read a lot about it. And first of all, we'll look at the language here. An increasing body of observations gives a collective picture of warming. Okay, the 20th century is warmer than the previous several centuries. That's no big deal. What one has to do now is prove, of course, that man-produced carbon dioxide from the use of fossil fuels, coal oil, and natural gas is somehow causing the temperature to rise. That's not so easy. The observed changes have been documented, and there are trends. Well, that's a no-brainer. That says nothing. The global average surface temperature has increased from the mid-19th century. Thermometer records, you may recall, go back to about the mid-19th century. And was the 19th century unusual? Yes, it was unusually cold. Was the 20th century warmer than the 19th century? Yes. So there's been a temperature rise, big deal. The global average rise has been about 0.6 of a degree centigrade. The trick, though, is proving that this has man causes behind it. And then here comes an interesting sentence. I'm going to step over because I can't see it very well here. This value is 0.15 of a degree centigrade larger than that estimated from the second assessment report in 1994. Okay, so they're saying there's been 1,500 centigrade of a degree rise just since 1994. That's pretty scary. Well, let's look at a good global temperature record. And this one is made by satellites. Willie might talk about it. I'll talk about it a little later. This goes from 1979 to the year, to the end of May this year. It's a monthly record. And it shows, by the way, no major warming trend, no net warming trend that would be there from the human signal. But I wanted to point out from here, I want to isolate this interval 1995 to 2000 for you that the IPCC makes a big deal about. Now you see that little spike there in that in between that 5-year interval there? That was the 1997-98 El Nino. This is a completely natural phenomenon, a warming in the southern Pacific Ocean that in turns warms the air above, and it's such a dramatic warming that it warmed the entire globe. But you can see rather than a catastrophic runaway effect from that, things cooled pretty quickly. But to say that somehow this is more evidence, with the implication being man-made warming, because we had an El Nino spike in this 5-year interval, this is marketing, this is not science. All right, we'll go back. The next point we're going to look at is new analyses of the magnitude of the warming during the last century in the northern hemisphere. Well, let's look again at the, oh yes, that's right, okay, and it's likely that 1990s was the warmest decade and 1998 the warmest year. Please. This is what I will focus on the IPCC. Willie will focus on the modeling efforts. Of the last 1,000 years, efforts have been made to reconstruct the climate to ask this question, is the 20th century unusual? And remember, once you answer that question, you then have to say, is that unusualness of the 20th century caused by human effects? So the first part of marketing this idea is to say that, over some fantastically long period, like a millennium, 1998 was the warmest year of all. So here is the reconstructed record, the dark line, and a smoothed line through it, plus a trend line through it, and yellow surroundings of it trying to indicate some sort of uncertainty level. Tacked on to the end of that record is the instrumental record showing a 20th century warming compared to the 19th century, and of course 1998, that El Nino year, which is, and saying that that was the hottest year in 1,000 years. We're going to look at this in detail. I just want to set the stage for you. But remember again that 1997-98 was this natural El Nino phenomenon. And looking beyond, and if we could go back to the satellite record again. Remember, after 1998, things cooled right back down to the long-term average. So having the report come out in 2000, having the analysis stop right around 1998, 1999, right at the peak of this El Nino, this El Nino is disappearing, well, that's pretty convenient from the marketing point of view. All right, back to the, and now I'm going to jump down here. Temperatures have risen in the past 4 decades, and since the 1950s, the period of adequate observations from weather balloons, there have been trends in the lower atmosphere of the air temperature of about 1/10 degrees centigrade rise per year. Now we're getting more interesting scientifically and marketing-wise. The 20th century was warmer than the 19th. And in order to make a link to man-made causes, one has to remember that most of the greenhouse gases from human actions were put in the air in the last several decades. So looking at warming that occurs early in the 20th century tells you that that warming is natural. You know that that's not man-made because most of the carbon dioxide hadn't yet been put in the air from human activities. So it is more scientifically appropriate to look at the last several decades. So this is what the IPCC does. If we can put up the balloon record. Records taken of the layer of air, the bottom few kilometers of air, where the carbon dioxide effect is meant to be felt first. And here is where something that you won't often read in the newspapers. If you add carbon dioxide to the air, the theory says that the energy will first warm this low layer of air, the troposphere. That, in turn, in the computer simulations, says that the surface will respond to it, to the warming in the troposphere. So the scientific test is set up. The computer simulations say you warm this low layer of air the first few kilometers, and then you warm the surface. So you have to have both warm, not one or the other. So there has been surface warming, and then they point to the lower troposphere record and say, well, since the balloons were launched in 1957, 58, there's been this warming there, so we think that this is the human signal. But that's the trend line they draw, this 10th degree C per decade. But if you look carefully at this, and if you know something about climate, you realize that something unusual happened in 1976 to the climate that has no man-made explanation. That is, from the time the balloons were launched to about 1975-76, there was no net change in the temperature as carbon dioxide was increasing in the air. Then the climate seemed to warm quite suddenly, all on its own, all quite naturally, because no computer simulation predicts this sort of jump. And ocean temperature shows this, many climate parameters show this. And since then, since that jump, there has been no net warming trend. So it's a little misleading at best to say that there has been a long-term trend since the 1950s. That long-term trend is mathematically real, scientific, and scientifically meaningless. There was instead two epochs, each of which have no temperature trend. So the human effect can't be seen even in this longest database that the IPCC points out. Yeah, let's go back to the readings. All right. Yeah, now another page. And I love this language. Confidence in the ability of models to project future climate has increased. Nowhere in this, and Willie is going to talk about the models, nowhere in this and nowhere in the document does it ever say that the models are scientifically validated. The models cannot project, they cannot predict, or they cannot project climate now. They can't predict El Niños. They can't explain El Niños. They can't explain the North Atlantic Oscillation. They can't explain sea ice variations. They can't explain the way clouds form. There are no major features of the climate that the models successfully reproduce. The models have 5 million parameters in them. We know we don't know many of those parameters. One has to make guesses. There are 10 million trillion degrees of freedom in the models, as 10 to the 19th. That means we can't run them on the fastest supercomputers except to make a run of climate several decades long. A prediction of, say, 100 years into the future would take 10 to the 34th years, and the universe is only 10 to the 15 years old. So even bigger computers aren't going to help, especially when you don't know the physics. So it's essential to make your simplifications, that's legitimate, to make your parameterizations, make your guesses, make your estimates, and then compare them to observations. And that's where the models fail. Nonetheless, in this whole document, and the policymaker summary says so, it says all this evidence is based on modeling. So all this evidence that they point to is based on failed models, models that fail scientific validation. So I won't talk about the different aspects of this because Willie will talk about it, but I'll come down to the next large bullet there. There is now stronger evidence for a human influence and on global climate since the second assessment report, and that was the one that came out in 1995-96. Then they so thoughtfully add for us the quote, the SAR concluded the basis of the balance of evidence suggests a discernible human influence on climate. Now, I didn't bring up the second assessment report. They did. Thank you very much. Let's look at what they did in the second assessment report. It should be the Michaels and Knappenberger. Yes, thank you. Now, in the second assessment report, this chart wasn't quite shown because in the second assessment report, this paper that was mentioned had not yet come out in press. It was just alluded to in press. The trend and the lines in dark were described. It was described as, and this is the measurement of temperature made by balloons of the low layer of air over the southern hemisphere ocean. This is a very good scientific test of the models because the models say that this is the region of the atmosphere that should warm the most and not be influenced by the confounding effect of aerosols. And they talked about how an upcoming paper would show that this trend verified the models. The second assessment report came out, all the publicity with it, and all the policy nonsense that goes along with it. And then this paper was published showing only the data in the oval there, and the trend line. And several people immediately sent in papers, and this chart was published by our colleagues Pat Michaels and Phil Knappenberger. and said, wait a minute, why did you just use the data, the subset of data? Here is the entire range of data from the time the balloons were launched until the then present. And if you look at that, if you look at the entirety of the data, there is no net trend. There's no net warming trend. So I would not brag about this being, being good evidence, and on this now you've got better evidence. This doesn't seem to be a good starting point. So the stronger evidence that they have, well, it wasn't strong in the first place. And finally, on the next page there, it says, there is a longer and more scrutinized temperature record. And it's based, and I can't read that, Willie, can you? There's a longer, more scrutinized temperature record. The top bullet. And new model estimates of variability. So notice these two things. We're going to look at some data, but we have to rely on models to interpret it. And the years since the second report, there has been work on getting this 1,000-year reconstructed temperature. So that's the main topic now. So why don't we move on to this? And that's the chart we just showed you, right? This comes from the first assessment report. And it's an overview, and it's more qualitative than the axes indicate, where they have temperature. I would just say warmer and cooler. On different time scales, starting at the top on the longest time scales, going back about 1 million years, showing that the current state of the Earth's climate is one of extreme cold, as the Earth now spends 90% of its time in a major glaciation, where the northern hemisphere is substantially covered with ice sheets. And we only every once in a while, the dotted line is the temperature now, every 100,000 years for about 10,000 years, emerge from those states of major glaciation into these interglacial warm equable periods, this one called the Holocene. But the Earth's preferred climate state right now is utter cold. And the second chart blows up the period emerging from the last ice age, about 12,000 years ago, and showing again some of the features that have been discovered. For example, a very long warm period about 6,500 years ago, and again the dotted line, today's temperature, so warmer than today. And then the bottom chart was the 1990 reconstruction of the last 1,000 years of temperature, showing a medieval warm period from about 1,000 years ago, the start of the second millennium, for 200 or 300 years, a drop into a prolonged cooling called the Little Ice Age, and then the ending of the Ice Age around the mid-19th century, with the 20th century recovery from that. So that's the backdrop of the 1990 report. This is what most climate experts had believed for a long time, and then along came the IPCC report showing the last 1,000 years. And can you grab that earlier chart of right? I'll try not to do that for you. Yeah, but now we have deconstructed these well-known climate features and come up with something that says there is little going on until humans really erupt in the 20th century with emissions of carbon dioxide to the air. So I call this marketing, and we're going to see why now as we look in detail at these records. Now I want to start, the papers these are based on come from Nature and Geophysical Research Letters, so they're in peer-reviewed journals, but I really have to question the peer review. The first paper on which this is based says that Hubert Lamb, who is one of the leading climatologists who was able to look at reconstructed climate, Lamb in 1965, examining evidence mostly from Western Europe, never suggested the medieval warm epoch was a global phenomenon. Okay, that's one of the reasons this author is believing his reconstructions. And then when everybody rebutted and said, you know, Lamb did an awful lot of work reconstructing climate and said there was a global medieval warm period back in the early part of the second millennium, his response was to write in print in Nature that Lamb was looking at Western Europe and he never suggested the medieval warm epoch was global. Here is what Lamb, in the paper that's referenced by the author, said in his 1965 paper. Multifarious evidence of a meteorological nature from historical records, archaeological, botanical, and glaciological evidence in various parts of the world, from the Arctic to New Zealand has been found to suggest a warmer epoch lasting several centuries between AD 900 and 1000 and 1200 to 1300, both the little climate optimum in the early Middle Ages and the cold epochs, the Little Ice Age, now known to have reached its culminating stages between 1550 and 1700, can today be substantiated by enough data to repay meteorological investigation. So Lamb was saying there was enough evidence that these phenomena were real, the medieval warm period and the Little Ice Age. And he was saying, let's look harder for this and really try to document it. And contrast that with what the author of this dismisses, is where he says, Lamb, examining evidence from Western Europe, never suggested this was global. Now, Lamb just said, from the Arctic to New Zealand, from various parts of the world. I can't even understand how this sentence, why this sentence is in there. There's a complete misreading of what Lamb wrote. Now, Lamb had then gone on 10 years later to come up with his own quantitative evidence on this. And he had worked looking at glacial advances and retreats and trying to define area by area of the world where he had information where and when the warming was and where and when the cooling was. This 1977 work of Lamb is never cited by the author of the 1999 paper, and one can only imagine why. All right, well, if we now bring this paper up, it's time to look at what is in this record and what is in, for example, Lamb's record in contrast, and that's the heart of this talk. This is a reconstruction of climate, and except from the red interval there, which is the instrumental record, a reconstruction of climate based on the growth of tree rings. And now I think we have some fun information for you. These are bristlecone pines in the western United States, and I think the oldest of these was more than 2,000 years old when Christ was born. So some of them are quite substantial, and his name is Methuselah, and his location is hidden. But the scientist here is going to bore into the tree and then pull out records of the tree rings. And for example, then lay these out in strips. These are magnified, and I believe the one marked 18, Willie, that's the 1800s? I think 1816 is the first line that's marked there, and you'll see a very, very thin growth ring in the tree, the annual growth ring. And that's because there was a huge volcanic eruption that year, Tambora, and caused in New England, for example, the year without a summer, and it was snowing in June because the volcanic emission had cooled the climate. So by looking at the annual growth of tree rings, scientists decide whether local climate was advancing or retarding the growth of the tree ring. And one of the reasons of the advancement or retarding of the growth is temperature. So one tries to pull out the temperature effect from these tree growth records. This is about, on my view graph, its actual size. The tree isn't more than about 8 inches in diameter, and it's one of the most high latitude growing trees. It's a Siberian larch, and it's 600 years old. And here the growth rings are very, very shallow because it's hard to get any growing season in Siberia. But nonetheless, these tree growth records and tree ring width and density come from all over the world and give very valuable information. So now let's look in detail at the records that went into producing that UN document. First of all, we've taken off the instrumental record, and we've just shown the reconstruction from tree ring growth. So two things to note here. One is that although there's a long-term trend over the second millennium that is a long-term cooling, there isn't the medieval warm period and the pronounced Little Ice Age that we saw from the earlier records from the IPCC. Then there is the huge late 19th century, early 20th century warming, and then I've blown up the last portion of that record in the next view graph, the last several hundred years, to show you two more things. First, the warming that occurs in the 20th century occurs early in the century and predates most of the emissions of carbon dioxide to the air. And second, since the peak of the warming early in the 20th century, the tree growth says the temperature should have been declining, at best flat, and certainly no warming. So without sticking on the instrumental record, the tree growth doesn't give you the right information. And yes, now here's the problem with the calibration. You have to look closely at this. The tree growth records that we were just looking at, or similar to that, are the open triangles. And maybe I can point out some of them. Here in the early part of the 19th century, and then here's the decline. So it's cool, warm, and then decline according to the tree growth. Now the instrumental records are the open circles. Now these two records hardly match each other. So I don't know how you can take this kind of tree growth record, which has a completely different shape, and then make it match up here, and then believe anything going 1,000 years backwards. And in fact, the climate scientist Wallace Broecker, commenting on this on the recent UN report in the journal Science, said that, as many tree ring experts know, it is very hard to get long-term trends out of tree growth estimates. The reason being that tree growth, as a tree ages, the amount of the size of its growth ring declines with age. So you have a constant battle here, because if you use one tree, one very old tree, you're getting ever and ever smaller amounts of growth each year, despite what the other climate parameters are doing to stress the growth, to change the growth. So you have a problem that the tree itself has filtered out any long-term information that you wish to build. So in his estimate, you can't really use tree ring records to do anything to look more than, say, decade to decade changes. You certainly can't look over millennium, and you certainly can't do that if you have only 100 years of instrumental data, and your instrumental data don't even match up with what the tree ring growth record is saying. Okay, now we're going to look at the 12 records that went into that 1,000-year compilation. And here they are. They have unusual names in the first column. But look at the second column where the tree growth says North America, and then in bold and italics, numbers 6, 7, and 11, 12. Those are from South America. Yet the the record that I showed you, the papers and the UN report, this is the reconstructed temperature of the northern hemisphere. And why records 6, 7, 11, and 12 from Tasmania, Patagonia, and Kilkaya are in the reconstruction of the northern hemisphere is never mentioned either by the UN or by the authors of these original papers, or I must imagine by the referees. So how the southern hemisphere growth rings from, say, Tasmania help you reconstruct the northern hemisphere temperatures is beyond both of us. One other thing to mention is Morocco. Although the paper says that these are all available at a website, Morocco was missing in action on the website. It just never appeared. Now the next chart, don't try to read anything except we've taken all the authors' charts that were available except for Morocco missing in action there. Squish them down, and I want you to look. These are all 1,000 years. So 1,000 years ago to 1997 or so. Well, this 1980 is when he stopped the reconstruction. And then tell me how you add these up, and then the ones boxed here are the ones from the southern hemisphere, so you can include or exclude those as you want if you're making a northern hemisphere record. So we have 1, 2, 3 across the top, 2 here. Morocco's missing, this one, and this one. How to add those up to show what the paper and the UN show, namely this shape. I don't get it. I don't see in any of those records that the 20th century is warmer than the rest, except in the Tasmania record, but of course that's not northern hemisphere. So this is also beyond us. What's the next one? Okay. Now, just to finish up on the tree rings here, there are major assumptions in the work that I think are unjustified. For example, to compare to the instrumental record, the instrumental comparison is less than 80 years, and we showed you the mismatch between the instrumental record and the comparison record. There is a validation interval that's used to set that once you use 80 years of the instrumental record, the more 80 modern years, to calibrate your temperature change for the tree record, then you go back to the latter half of the 19th century, because that's all that's left of the instrumental record at that point, and use that to say, is it validated? So you have a much shorter validation record and much less accurate validation record. So it really isn't, it isn't appropriate. I mentioned another problem is that you can't really look at climate trends longer than several decades, owing to this factor, this effect that tree growth retards with age. So you can't get century or millennial scale information with these records with any kind of reliability. Now, it's odd, and also odd is that the UN record the UN record was based on one record only in the first 400 years of the second millennium. So the medieval warming was solely based on one record from the Pacific Northwest, which is a high, and it's also at a fairly high altitude. And it's well known among tree ring researchers that in the 20th century, these high latitude stressed growth areas have not been responding to temperature. The tree growth has not been responding to temperature. This remains unexplained. Some people look at air pollution as explanations, but there is no good explanation. But how you can dismiss the medieval warming on the basis of a record which you know to be flawed in giving you the 20th century and accurately reproducing the 20th century is also beyond our ability to comprehend. All right. Now, why don't we look at some of the information that you can bring to bear on reconstructing the climate of the last millennium. Some of the information is diary-like or descriptive or anecdotal. These are landscape paintings, for example, during the Little Ice Age period that describe to you what seasonal changes are. These are an account from a medieval manor in London saying that what's the date on the 1342, there was a great drought in the summer that caused an increase in the price of iron for their plows and their horseshoes. So by looking at some of these diary results, these written records, you can reconstruct climate information. You can also go back and do archaeological evidence and paleo and anthropological evidence. This is the city of Petra, which was a huge trading center, and it's now been consumed by the Jordanian desert, which expanded and grew as cooling swallowed it right after about the first or second century A.D. Can also do more quantitative things from geological reservoirs, for example. These stalactites and stalagmites carry in information that in the water and mineral content that drip down and build these things. So by looking at the layers and the isotope composition in the layers of the stalactites and stalagmites, one can reconstruct some local climate information. One can look at growth ring in corals. The organisms in corals exude material that and builds up, and by looking at the material in the growth rings, you can tell some local climate information as well. And then finally, you can look at very quantitative information from the advance and retreat of glaciers all over the world, not only at the northern and southern high latitudes, but remember glaciers occur in mountains throughout most of the world, so there are tropical glaciers. This is a glacier from one of the, collected by or highlighted in an anthology by Gene Grove, one of the leading experts in looking at glacier advance and retreats. And here the record goes back even before about 1,000 years, from 750 to about 1950. And this has the glacier extent in the Alps. The glacier retreating means relative warmth. The glacier advance means relative cold. Here's the medieval warm period. Here's the Little Ice Age. And here's the present warmth.
It's at the timing of precisely where the position of the glacier.
Right, so the peaks, she's taking the modern era and saying where do they correspond on the peaks and troughs compared to the last. But this clearly shows, without the problem of tree ring growth, this shows longer term, centuries to millennia episodes. Now, there isn't you should note that there's advances and retreats within the advances and retreats. So although the medieval warm period is a sustained several hundred-year periods in the Alps, starting in about 800 AD, and then there are advances and retreats within that. So it isn't uniform, but on the average, here there's a warmth, and on the average here during the Little Ice Age, here there's a cold, and returning to a warmth. So one can document glacier evidence from all over the world. One very good piece of data that we have comes from the drilling of ice cores, and these are the boreholes left after the ice cores are exhumed. And the boreholes have the temperature of the air going down in depth that tell you what the temperature of the surroundings were when they were laid down. And this is very interesting, tricky, difficult analysis, but some brave people have done this. And this has going back 8,000 years from Greenland, and showing the Holocene optimum, the warm period here, declining into a cool, warm, cool, warm, cool. And then here's a blow-up of the last 2,000 years. Again, here's the medieval warm period, a sustained high period. Here's the Little Ice Age, and here's a little bit of warming, cooling, and warming. The medieval warm period on that was warmer than today. These boreholes, dug for a variety of reasons, for mining or just for geological work, exist in many places all over the world. And this information has been compiled by researchers. And although they have some uncertainty when they try to invert the borehole measurements into a temperature measurement, you can follow either any of the curves. But in each case, here's the Holocene optimum, the warmest of the last 10,000 years. The medieval warm period, the warmest of the last 1,000 years. The Little Ice Age, and not as warm as today. The middle today is not as warm as even the medieval warm period of 1,000 years ago. There's also information that comes out of the layers in ice cores, and this is from Greenland over the past 1,000 years. Medieval warm period, Little Ice Age, and then today's warmth, which is not as sustained as the medieval warm period, certainly in Greenland. Now, information by information, Willie has compiled this with me. We've taken documentary evidence, ice cores, glaciers, boreholes, the stalactites and stalagmites called speleotherms, tree ring growth limits, that is the limits to where you find tree growing, glacier limits, peat cellulose, pollen, phenological records in China, that is sort of diaries of when wells and lakes were last frozen and what kind of trees were blooming when in the spring, seafloor sediments, lake fossils, coral, and then the tree growth records. And we asked 3 questions because it's hard to intersplice these records and come up with one quantitative reconstruction. So we ask it individually of each one. Was there a medieval warm epoch in the record? That is, was there a relative warming back in the early part of the 2nd millennium? Was there a Little Ice Age? And was the 20th century the warmest of that record? Now, in some cases, the 20th century isn't covered in that record. So, for example, there's a dash there, or the Little Ice Age wasn't covered in there. So yes means it was covered in the record and it says so. No means it was covered in the record and doesn't say so. And if you look down this column, the medieval warm period exists in all these records where there's information on it. The Little Ice Age exists in all these records where there's information. And is the 20th century the warmest? It is no, with a few question marks because it's hard to tell, except where I've highlighted in pink, where we've said that the 20th century is the warmest in their records. For example, the Tasmanian growth rings, or tree rings, say that yes, the 20th century is the warmest. Warmer than the medieval warm period, which does exist in that record. In Alaska, we don't have information on that record of the medieval warm period, and that is also true of the near Arctic and Mongolia records. So except for Tasmania and these 2 high latitude records, and for 3 of them there isn't even information going back to the medieval warm period, the 20th century is warm. But owing to the problem of tree growth not telling you accurately about long-term trends going back a millennia or so, and owing to the fact that there are many other records that tell you that the medieval warm period existed and the Little Ice Age existed, we have to reinstitute the record that was put out by the first IPCC report, namely that there was a medieval warm period that was warmer than today. Okay. Oh, and here are some other examples. This is in Africa, and here's the medieval warm period, the Little Ice Age, and this is from lake fossils, seafloor sediments. Right. Oh, this is stalagmites and seafloor. All right, another one. This one, Art Robinson has published in Access to Energy. This is peat cellulose from China. Goes back to the Holocene optimum warmth here and beyond. There's the medieval warm period, the Little Ice Age, and the present temperature, not warmer than either the medieval warm period and certainly not warmer than the Holocene optimum, all before there were SUVs. And one other scary thing we read about, we thought we'd highlight the borehole record from Greenland. Sorry, not the borehole, this is the ice core record from Greenland. And this is going year by year, and we chose two periods from, or these authors chose two periods from the Little Ice Age in Greenland. And I want to show you the annual variation. We often hear in the newspaper that breathlessly the 20th century warming has been more profound than any period of warming. And first of all, it's not more profound, for example, than the 1997-98 El Nino, where the temperature rose 0.8 of a degree centigrade within half a year. And then calmly, after the El Nino was over, it just dropped right back down. But here are temperature swings of some of these, certainly within a few years and shorter than a decade, in Greenland, of the average temperature of 6, 7, 8 degrees centigrade. So there are enormous short-term variations on climate. So when you read in the newspapers that the 20th century warming has been unprecedented in scale and magnitude, you can just laugh. They know zero about climate change. And finally, in the last records, Willie has compiled the information we have and asked, can you see a Little Ice Age in the records that exist? And this is to get back to the idea of Lamb, who said looking at multiple proxies and looking from the Arctic to New Zealand, and in fact we can now look down in the Antarctic, what does one see? Worldwide in scope, was there a Little Ice Age? The red regions and areas mean yes. The green means no, there was not a Little Ice Age. And I think the only green point on here is Tasmania. And then can't tell is in blue. The Little Ice Age was worldwide and pervasive, yet it's not in the current UN-approved reconstructed record. It just doesn't make any sense. The UN record, that is. And then this question said, going back further in time, was there a medieval warm epoch? And here, again, the red regions and areas mean yes. So from the Arctic to New Zealand or Antarctica, in Lamb's words, yes, there was. No is in green, and here I think there's a... In the Himalayas. The retreat of the glacier of the Himalayas wasn't so profound during the medieval warm period. And then can't tell, again, in blue. So some areas in blue, but mostly in red from where we have information. And finally, is the 20th century the most extreme, the warmest and most extreme? The red is yes, and I can see, let's see, here's one. The Himalayas, somewhere in China, is this China? Russia? And then the greens mean no, the 20th century is not the warmth. Orange also means that it's marginally warmer. And then
It's because the warming is peak at 1920s and 40s, so it has no relevance to the CO2 question.
right, so here there was warming in the 20th century, but there hasn't been recent warming in those areas. It's the rapid early 20th century warming. So in some sense, this is a difficult question related to the amount of carbon dioxide in the air, because you have to know what it's done more recently. And then finally, the blue means can't tell. But again here, no, the 20th century is not the warmest in most of the records. and the orange ones are really ones we can't, that certainly say no with respect to carbon dioxide being the cause of the warming in the 20th century. And if not SUVs, what caused that past warming? Willie and I have worked hard on looking at changes in the sun as the cause, changes in the sun's energy output. And this is a chart of changes in the sun's magnetism going back to the year 800, reconstructed, and this is measured in the isotopes of carbon-14 and beryllium-10, carbon-14 from tree rings, beryllium-10 from ice cores. When the sun's magnetism is strong, there is less of this isotope present in these isotopes present in these reservoirs, and both the beryllium-10 and the carbon-14 have been set to a carbon-14 scale in this chart. But in this case, we're trying to show that the sun's magnetism changes on timescales of decades to centuries. So the sun's magnetism was very high, because this is an inverse indicator, back here in the early part of the second millennium, then dropped to low levels, and then has since recovered, not quite as high as the early part of the second millennium. And we know from modern satellite measurements that the sun's magnetism changes in step with its changes in its energy output. So changes in the energy output of the sun are a likely and easy explanation for saying the medieval warm period was likely contributed to, if not O's main explanation to, the enhanced magnetic and energy output of the sun, little ice age, the sun's dimming, and very low magnetism, and the recovery, the sharp recovery in the early 20th century. So we see the sun's imprint going back at least 1,000 years. And this is just to remind you what the sun's been doing. Its magnetism has been growing steadily in the last 400 years of telescope records, meaning its energy output has been steadily growing, and it's growing at such a cadence that it matches up extremely well with the temperature of the Earth. And so, Willie, could you put on them?
Is that 11 years between those peaks?
That's roughly 11 years between the peaks and the trough. And what we did was we took the envelope of that and plotted the changes in northern hemisphere temperature for the Earth and the changes in the sun. And they match up extremely well with very little room for a human effect from increased carbon dioxide in the air.
I emphasize not for 1,000 years. Right.
This is not 1,000 years. This is 250 years. When we get from the climate folks some good temperature records, that is, when they can put together in a quantitative way all that temperature information from those proxy records going back 1,000 years, then we can try to look at the sun's influence going back 1,000 years. Now all this, the final view graph this is one of my favorite facts from NASA's website, and shows the problem we've gotten into in marketing these results. Not we, but the problem society has in listening to the marketing of these results. Is the Earth experiencing a warming trend? I expected to see in the first sentence of that response something about measurements. Instead, the response is, computer models predict that it is. I have a lot of trouble with that, because is the Earth experiencing a warming trend? My goodness, we have measurements.
If you allow me, I'll mark it in red.
Yes, please. But no, we're not going to look at measurements at all. We're going to rely on computer models. So we've marketed the models. The models have been marketed so thoroughly that we now have nonsensical statements that are unscientific. Is the Earth experiencing a warming trend? Computer models say that it is. And that's enough for international negotiations and the threatened collapse of the US economy based on making dramatic energy cuts for an effect that can't be found in any of the best observational evidence. D.D. Harriman, my hero in my science fiction story, must be very upset. Thank you. We can do questions? Yes, please.
In your earlier publications, you relied heavily on data from the Sargasso Sea. I noticed you didn't here.
I have many more charts, and that one is in our, can you pull out the table? We do have that in our table. And just that we've shown it so much, I just thought I'd show something else.
And how do you develop sun data going back 500, 600, 700 years?
telescope records of the sun go back 400 years to the time of Galileo first looking at the sun with the telescope. Then earlier than that, records for the sun can be gotten back almost 10,000 years, and soon will be gotten for 400,000 years. And
What are you measuring?
the reason is, what you're measuring is the amount of carbon-14 in tree growth, or the amount of beryllium-10 in an ice core layer. Both of those isotopes, the more abundant isotope is carbon-12 or beryllium-8. Both of those isotopes are formed in the upper layer of air when cosmic rays from deep space hit the top of the Earth's atmosphere. In the case of carbon-14, a nitrogen atom gets hit, a nitrogen molecule gets hit by cosmic ray. It's changed into carbon-14. It eventually associates with oxygen, becomes carbon dioxide. Tree breathes it in and incorporates it in its cellulose. Now the sun comes into the picture because the sun's magnetic field, when it's strong, tends to deflect more of these cosmic rays than when it's weak. So by looking at carbon-14 or beryllium-10, you get to see the changes, the overall changes in the sun's magnetic field as this amount of isotope in these reservoirs has changed over time.
Where will you get this data 400,000 years back?
The ice core records in Antarctica go back 420,000 years now. So by measuring beryllium-10 in those records, eventually, and there's someone in Switzerland is starting this measurement, and it's extremely difficult because there isn't much beryllium-10 in each layer. But that has the potential of looking at the sun with getting a record of the sun with a resolution of about 2 years time, because the beryllium-10 formed in the atmosphere and falls out with precipitation within a couple years usually. It gets deposited in the ice core and then builds up. In the case of carbon-14, there's some chance that you don't get any information on the 11-year cycle. You only get the long-term multi-decade swings. And the reason is that the carbon dioxide moves, once it's formed in the air, it might stay in the air for a while, it might get absorbed in the ocean, then finally might get into a tree. So you've lost any short-term information on the 11-year cycle. But beryllium-10, because the residence time before it hits the ice core layer is so short, we're going to see the 11-year cycle going back 400,000 years, which is a factor of 10 times longer than we have information on it. Factor of 100 times longer. Yes?
Why are governments ignoring the data?
Well, as I tried to allude to about marketing, that we would rather think of a pretty story, we would rather dismiss it, we would rather look away at the tragedies of today and pretend we're doing something about a problem. I just don't understand it personally, and I try to remain immune from it, but it's a complete abuse of science. It's also abuse of marketing. And I can't tell you why specific people are doing that. I have no idea what their motives are. Some of them, everyone thinks their motives are proper, but I think it depends on the outcome, not whether or not you think your motives are right.
Has the IPCC included your data and discounted, or have they not referenced you and the solar cycle data at all? That's the first partial question. The second question is, previously, either you or Dr. Soon, I think, showed correlations between CO2 and temperature that implied that the ocean surface temperature was driving the CO2 rather than the so-called greenhouse gases driving the surface temperature.
Right. There are two things. We were asked by the IPCC to send our publications, and we did. We were astonished to find, I can't recall the language exactly, but it says because the work on the sun is not highly developed theoretically, that they were then not going to believe it. And if you contrast that with the theoretical development, the handling of, say, water vapor, the most important greenhouse effect, I just couldn't understand the parity of that criticism. It held no water for me. And in the IPCC report, they in fact say that the sun, even though they don't believe any of this, they say the sun has been dimming over the sun's contribution has been negative over the last several decades. I don't fully understand how they can say that. I mean, therefore, with the implication being that the sun has not been contributing any warming whatsoever. In fact, it's been cooling, and I guess the implication is therefore the warming is worse than we thought. The other question was on...
Does the ocean surface temperature drive CO2 and greenhouse gases?
One of the, if you read Al Gore's book, Earth in the Balance, the strongest evidence that he provides for carbon dioxide driving large temperature change and the current large buildup of carbon dioxide driving large temperature change is that when you look at the ice core records, you can get temperature and carbon dioxide content of the air at the same time. And when you plot those two together, they go up and down together. And that's always been shown, saying, see, so you add carbon dioxide to the air. But the scientific question is, what is cause and what is effect? And there, if you look at the ice core data, and this has been true since the first ice core results were published in the 1980s, the temperature changes first, and the carbon dioxide changes follow. And the timing of that has become clearer and clearer. So what's happening is that the ocean and likely also plant feedback, that is, plants are absorbing and emitting more carbon dioxide as temperature changes. So the temperature is changing for one reason, whatever reason it is, and carbon dioxide, when it's warmer, is emitted from the ocean. When it's cooler, the ocean absorbs more, and you're seeing that effect. So the ice core records don't give you, they undermine that notion of carbon dioxide driving tremendous temperature changes. Yes, please.
Dr. Baliunas, I think it was a marvelous presentation.
Thank you.
I have a couple of dozen questions, but I'm going to ask you one. How do they determine the Earth's temperature from the boreholes? Does the borehole actually retain that temperature?
Yeah.
So that assumes very little conductivity, very little.
There's some, and the trick of this is looking at those air temperature measurements and then inverting it, and it's not easy work. And Willie, do you want to make a more technical comment?
No, I just want
Yeah.
to make a more poetic comments. There is somebody very distinguished who wrote Alice on the Wonderland, saying that boreholes sort of resemble some sort of a bad memory that only works backwards.
So yeah, you drill the borehole, and the layers remember
They actually
what is there.
preserve the
They preserve
temperature
some of
as
it,
they
right,
remain down.
right,
What-
right.
What sort of resolution does that measurement allow?
Very poor. It's on the order of centuries to centuries. Let's say within 2 centuries, let's say.
Okay, thank you very much.
Right. But we've looked at the borehole data extensively and think that it is reasonable for looking at millennia scale, century to millennial scale shifts.
It does pick up all the features that we
Right.
saw in the best possible results. Yes, sir.
And there are also thousands of these boreholes where there's good inter-agreement.
Potentially very exciting in my opinion.
Does it require that you get your data immediately after the whole?
No, no.
You just do repeated measurements and just add it to the statistics, actually. And it's useful, of course, to have measurements of the heat flow at different time periods. Then you have another way to constrain this profile. So you can derive a more accurate sort of temperature information over time.
I shouldn't waste time, I guess, but doesn't the exposure to atmosphere influence the temperature distribution in the hole? Once the core is removed, don't we get distortion of the temperature readings?
So the gradient goes very slowly. It's very, very diffusive. I think all the small time scale effect is really being washed out. Yes.
I just want to remind everybody that may have forgotten that when there was a lot of atmospheric testing of bombs, that a lot of people were blaming that on the weather. As a matter of fact, I remember there was an old cartoon called Grin and Bear It, which shows a couple primitive men saying, "I don't care what anybody thinks. We never had this crazy weather until they invented them bow and arrows."
I think it's a comment on human nature, isn't it?
Yes. My question is, where can we get access to some of these graphs and so on?
I'm always late in getting my charts available, but I'm going to Xerox them and send them off this week. And maybe we can include, well, I think we can include them in the CD-ROM.
Oh, okay. Great.
Yes, 2 questions. First, did this data make it into the recent review for the National Academy of Sciences report?
No.
Did not?
No.
And why not?
No idea. Well, the National Academy was asked to address a different question. They were asked to address what do we know about modeling climate change. They actually didn't answer that in a direct way. But we've compiled these and are about to send it off to publication, so it's in a handy format.
And then the second question was the graph that showed the sudden jump in 1975. Do you have a physical explanation for that jump?
I'm not. Do you have a good explanation that you've come across, Willie? It just, I can say two things. One, it appears in many climate indicators, and two, no model predicts it. So certainly it's not, according to the models, human-driven.
No extra comment except for getting the information is already hard enough. But I think the key point to note here really that the phenomenon is very much deep down into the ocean, which makes it even more so. I can at least say it in a scientific way that you try to rule out the effects of the CO2. If you want to rule out the effects of other things, like maybe the sun or other internal oscillation of the ocean dynamics, then you will have a much harder job. But it could be completely natural.
Okay, do one more? This last one.
The U.S. government seems to be aware of this, are they? Because they are pulling away from the Kyoto Accord. So what is driving it? Is it the economy or the science or both?
I have to admit, I do not know. I know I agree with President Bush. I mean, the Kyoto Agreement is unfair, unworkable, and won't do anything to address the fear that's on the table. There's the amount of carbon dioxide that it asks developing countries to address is nothing if you believe the computer models. You're addressing, by having the U.S. cut, you're addressing a few hundredths of a degree centigrade change in 50 years. So he did the right thing. What his reasons were, I just don't know. And I want to thank Willie, especially.